Hi, I'm Cheryl Leach. In this problem, we're going to be looking at finding the equation of a tangent line to a curve at a couple of different points. Well, what do we need to do? We need to find the equation of a line. And not just any line, but the equation of a tangent line. Now, to find the equation of a line, you need two things, a point and the slope. We're given the 2 points that we'll be working with in this problem. However, we also need to find the slope. And the slope is going to be found by using the derivative. So let's begin by finding the slope of any tangent line to my curve. The slope is going to be dy dx. But when I look at my equation, it's not solved for y. So I'm going to need to use implicit differentiation to calculate that derivative. So in implicit differentiation, I want to differentiate both sides. On the left-hand side, my derivative is 2x plus 2y dy dx. And on the right-hand side, I just have a 100. The derivative of any constant is 0. So at this point, I need to solve for dy dx. So I'll isolate the term that includes dy dx on one side and move everything else to the other side. So I have 2y dy dx equals negative 2x. Next, I'll divide both sides by the 2y so I can isolate my derivative. dy dx equals a minus 2x divided by 2y. One last thing, I can simplify by canceling my 2's. And the slope of the tangent line at any point along my curve is negative x divided by y. All right, now let's move on to the first point. I want to find out what the equation of the tangent line is at the point 8, 6. So again, I need the slope and the point. So I can calculate the slope by using the information that I calculated in this last piece. So in this example, my x is an 8 and the y is a 6. So my slope is going to be minus 8 divided by 6, or in other words, negative 4/3. Now I have the point and the slope, so I can go ahead and use my point-slope formula. Y minus y1 equals m times the quantity x minus x1. Plugging in the appropriate information, I have y minus 6 will equal negative 4/3 times the quantity x minus 8. I now need to solve for y. So first I'll distribute the 4/3 across. I have y minus 6 equals negative 4/3 x plus 32/3. And then I'm going to add 6 to both sides. Now remember, 6 is the same thing as 18/3. So when I add 6 to both sides, it's like adding 18/3 to both sides. That makes the arithmetic a little easier. So the equation of my line is negative 4/3 x plus 50/3. That's the equation of the tangent line passing through the point 8, 6. The problem doesn't stop here. It wants us to do this process again when the tangent line passes through the point negative 6, 8. So let's try it again. Once again, I need the slope for this particular line. In general, I know that the slope is minus x over y. So in this case, minus x over y will give me a minus negative 6 all over 8, which is 6 over 8, or 3/4. I have the slope, I have the point, I can go ahead and use my point-slope formula. Y minus y1 equals m times the quantity x minus x1. Plugging in the appropriate information, I have y minus 8 equals 3/4 times the quantity x minus a negative 6. A little simplification, I have y minus 8 equals 3/4 times x plus 6. I'll go ahead and distribute my 3/4 across. And I have y minus 8 equals 3/4 x plus 18 quarters. Finally, I have to add 8 to both sides. Now, when I add 8 to both sides, it's going to be convenient to think of 8 as 32 over 4. So I'll add 8 to the left-hand side, and I have 3/4 x plus 18/4 plus 32/4, which gives me y equals 3/4 x plus 50 all over 4. Now, one thing I should note is that 50 over 4 can also be reduced to 3/4 x plus 25 halves. So now I have the equation of the tangent line going through the point -6, 8. At this point, I think we should use our graphing utility to verify and visualize these results. So one thing that's nice about a graphing utility is many of them will allow you to graph a circle. And so if you go into the draw function, you can select a circle with center 0, 0 and radius 10, because that's what our equation indicates that we have. Now, it'll be nice to make sure that you have an appropriate window for this. Because our radius is 10, maybe going from -15 to +15 on both the x and the y axis would be a good choice. Once we have our circle, you can go ahead and graph the equations of both of these lines. So we'll enter -4/3 x plus 50/3. And then we'll also graph 3/4 x plus 25 halves. And when you graph them, you should see both lines and the circle all on your viewing screen. Now, another thing that's kind of interesting is that you can actually see the point of tangency for each of these curves. So let's go ahead and make sure that you select the line that goes through the point 8, 6. Once that's selected, then evaluate the function when x equals 8. And when you do that, the cursor will move right to that point of tangency along the curve, and you can see that the line hits the circle right at that point. You can do the same thing for the next problem. Go ahead and select the appropriate line and then evaluate at -6. So if I select that line and evaluate at -6, sure enough, the point of tangency is highlighted by the cursor, and you can see that this line is tangent to my circle. I hope this was helpful. Thanks.